Hello again, and welcome to the next part of my presentation on unit conversions. We've been looking a lot at how we can actually figure out converting from one unit to another. What I want to do now, I think a bigger point that we look at why it actually works and why adding the powers together and timesing the powers actually works. I'm not going into too much detail because I don't want to confuse you and take away from the fact that you can actually get the right answer. So if we look at these figures here, they should be quite familiar if you've looked at the previous presentations. They're the surface area of Mars in kilometres squared and surface area of Mars in millimetres squared, which we figured out before. And if you remember, we got this this 20 over here by adding this 8 and this 12 together. Yeah, we added this 8 and this 12, we get this 20, and then we added the 1.45. So we had 1.45 times 1 to the 10 times 10 to the 20 millimeters squared, and then we just simplified out, expanded the brackets. So why did we add this 8 and this 20 together? Well, what I've basically done is I've actually almost skipped out a step to make it simpler, so you can actually remember how to do it. The actual equation to get this, if we actually wrote it out in full, would be 1.45 times 10 to the 8, this figure here, times 1 times 10 to the 12. Okay, so here you can see we've taken the original figure in kilometres and the original figure, the figure we figured out as our conversion factor. Now, if you remember, like addition, multiplication is commutative. Okay, so we can rearrange this. So 1 times 1.45. I'll put that in brackets. Times 10 to the 8 times 10 to the 12. Okay, just to refresh your memory, commutative just means that we can do them in any order. So 2 times 5 is exactly the same as 5 times 2. So what does it give us? Well, we got 1.45 times 1. That's obviously 1.45. Okay, so 1.45 times, we've got here 10 to the 8 and we've got 10 to the 12. When you times powers together, you just add the power here and the power here together. So then we have 10 to the 20. Pardon me. Okay, which is what we got up here. Okay, so all I did is I skipped out that middle step, which involves rearranging the equation and fiddling about, so you could actually see how it works rather than faffing about with all this. And it's exactly the same thing. If you're converting like this, all you need to do is add those two together and it'll give you to the 20. Simple as that. Okay, one other thing we haven't looked at is the multiplication of the squared part to our conversion factor. If I flip to the next chart. Okay, you'll see why I've done it this way round in a minute, working backwards. If you remember in the book, there'll be a lot of questions that have something like, let's say, the square root of 4 times 10 to the 8. Okay, hopefully what you know is that if you're taking the square root of something like this, you just find the square root of the first number. So the square root of 4 is 2. Okay, and how do we do the powers? 10 to the power of 8. How will we do that? Oh, well, it's just half, isn't it? So it'll be 10 to the 4. So in a square root, you just divide the power by 2. Okay, same with the cube root. I won't do that because I haven't got a calculator on me. Okay, you just divide 8 by 3. It works the same for squaring and for cubing. So if we have 4 times 10 to the 8 squared equals, so we square the 4, that's 16, and then we square the power of 10 times 10 to the 16. Okay, so when we're square rooting, we divide it by 2. When we're squaring, we times the power by 2. And it's exactly the same as what we've been doing in these questions. Let's just change colour. Remember, to get to this figure here, we were timesing this by the power. Okay, so we're timesing, we're squaring 6. Okay, so exactly the same as here. So to square 6, you just times it by 2, which gives us our 1 times 10 to the power of 12. Hopefully that's cleared it up a bit for you and given you a bit more in-depth explanation. I don't really want to go into too much detail about it. I mean, if you want to know more, it's all in the book. You can read through chapter 3 again, and hopefully if you read it through again, it will start making a bit more sense now, because you won't have to worry about how to get the right answer. You'll actually be able to figure out how is this exactly working. Running out of time for now, so in the next presentation I'm going to look at the questions where we're doing two at the same time, so from centimetres per year to millimetres per day. And I hope to see you there. Thanks very much.